Hey, sixth graders. When we were considering studying for the science light, color, and sound tests, I thought that there's a bunch of kids that have been missing and trying to catch up, and maybe a video might be helpful. What we focused on were the notes initially. Did the PowerPoint, you filled in the blanks. I posted a filled out version of that on our Google Classroom already. Then I gave you a blue review sheet, stapled together, one-sided stapled together, and I went through that in class. What I'm going to do is I'm going to go through this kind of again on here as briefly as I can. I also offered up a cheat sheet for everybody to take notes on both sides. Anything you want could go on there. And then there are 3 tests. Today we took, for most kids that have been here and were ready, they took the light test, 2-sided, light and color. And then tomorrow, which will be Friday, there's going to be this purple sheet. That's a sound test, and it's only 1-sided. And then also Friday, there's a diagrams test. Okay? And I'm going to talk about preparing for those. Studying notes is great. Putting everything on your cheat sheet is great. Study guide, though, is what I want to quickly reference here. Okay. If we're just going to highlight some sound things on this light and sound review, which I'll also post for you, a blank one, and I'll take a snapshot of what I filled out, but good luck in reading my handwriting. It's terrible. Here's some stuff that you need to know. Number 1, you don't need to know the number 9, draw an eyeball. Excuse me, perfect health. You would need to know frequency, hertz, and decibels. That would be on number 12. Frequency, the number of times a wave passes a certain point in a certain amount of time. Hertz, the unit of measurement that measures the frequency. And decibels, that's measuring the intensity of the sound, pretty much the volume. And that's a unit of measurement as well. The next one, what's the difference between noise and music? Music is organized sound, noise is disorganized sound. What is sonar and what it's used for? Well, what is sonar? It's a device that uses sound waves to measure distances. And what can it be used for? It can map the ocean floor, it can look for sunken ships, it can look for fish finders, and probably lots of uses. And then other sound related, 17, why can't sound travel through open space like light does? Because it needs matter through which to vibrate. That's a perfect answer. Define an octave. That's a musical sequence. This is number 18, where the top note has twice the frequency of the bottom note. You're splitting those in half. Like a C, middle C, and then another C, and up, and if you're familiar with piano. 19, what is ultrasound? How's it used? Ultrasound is above what we can hear, what humans can hear, so above 20,000 hertz. Some animals can hear beyond that. 2 things it can be used for: looking at images of babies in the Prego Mama, and for physical therapy, like breaking up bruises and so on. There's other uses too, but ultra means above the sound that we can hear. Yeah, that's primarily the sound portion. Let me look at the actual test here, see what I'm missing. Frequency, decibels, hertz, difference between music and noise. What is sonar? How's it used? Oh, and sonar stands for something. That's the extra credit question. Okay, I'm not going to highlight it right now. You should have been paying attention in class. If you weren't, look it up. Light can travel through open space. Why not sound? Musical notes, octave. How is ultrasound useful? Oh, when you knocked on a surface, you put your ear here and then you put your ear here. Why is it louder? See if you can answer that question. That's basically it. And then when you go to the diagrams, again, I'll quickly flash it. Here it is. When you see a mirror, a convex mirror, and you get the arrows coming, what's going to happen? If you have a concave mirror, you get the arrows coming, what's going to happen? You got to finish that drawing. You probably can't see that because this marker is really light. Okay? So you'd have to draw what those three arrows do if they hit something like that, or if they hit something like that. And then, if it's a lens, well, then it's not ricocheting or reflecting back off. What's it do when it goes through? And remember, the one thing about that is the thicker that it is, the more it pulls on the light ray. So the middle one just always goes straight through, but this one here, notice it's thicker on the top. So it'll pull that light ray. It's thicker down here, it'll pull. I kind of equate it to like a thick mud that sort of will pull you off track. So if we think about that, and you get a lens that's thicker in the middle, and you get light coming through, well, we just put the middle one straight through, but it's thicker this way, thinner up here, so it pulls it. It pulls it. It pulls it where it's thicker. Hopefully that explains things. Okay, primary colors of light, primary colors of paint. You got to know the difference. And you got to know together what they make. So primary colors of light, you got to know what that one is, that one is, that one is, and then what it is in the middle. Now here you have these secondary colors, and secondary colors. And you can fill those in if you want, maybe for extra credit, we'll see. But those are what the primary colors of paint are. So if we actually go primary colors, I'm just going to draw the exact same thing. Primary colors of paint, that's a whole different group. But there's a primary color paint, there's three of those. And then what's in the middle here, it's different than light. Okay, light is white and paint is black. Blackish brownish. And then their secondary colors are what light's primary colors are. It's kind of fun. All right, look up those, make sure you know what those are. I'm not going to spoon feed it to you, which I kind of am. Electromagnetic spectrum, sing the song. I think your whole family needs to hear you sing it. I'm going to put here, starts with an R. Well, I'll say the first one, radio waves, and then there's one that starts with M, M. I, it's two words. Then you have the part that you can, that's my picture of an eye, that you can see, and that's two words. And then U, X, G. Now, if none of that makes sense to you, then you got to do more studying because that should make perfect sense to you. Okay, you need to know that. You need to know the parts of a wave. Okay, a transverse wave. Do you know where the crest is, the trough, the midline, and you have to draw the midline in, the amplitude, and what a wavelength is. Got to know all those. Oh, can you draw a compressional wave? I don't know if I did that with both classes, but here you got all these particles in the air. Well, let me space them out just normally. Particles just all in the air. But when you send a compressional wave through, then those particles come together. They condense, and then you got the odd particle kind of in between. But they're condensed. Compressional wave. Draw a picture that shows the difference between seeing lightning and hearing thunder. Well, you know what? We know that it takes 5 seconds to get to your ear. So here's a good one. Here's your lightning. And then here's you. With your big old ears sticking out. And here's 1 second. 2 seconds, 3 seconds, 4 seconds, 5 seconds. So let's go 2, 3, 4, 5 seconds. And we'd label this as lightning and then thunder. Parents are watching. I'm sure you're thinking, how did that guy ever get a teaching job with that bad a handwriting? I asked myself the same question. Okay, and then it'd be good if you got a head start on reading Exodus 19 verse 16 all the way through 20, not 120, 20 verse 19. And the question will be, what do you think the voice of God sounds like? Let yourself wonder about that. So there's no wrong answer. You just got to fill up the space and really just think and meditate on what do you think his voice sounded like. We're talking about sound and to actually hear God speak. And then it says to fill up that whole section there, just let your mind go and use complete sentences. It also says draw a rainbow, the Roy G. Biv. And when you do draw that rainbow, the longer wave colors are going to be the red. The shorter wave is violet. So your Roy G. Biv should look like that. That's a good one right there. And the extra credit for that test has to do with speed of something. See if you remember it. All right, hopefully that helped you out.